Okay, great. So this is the first for me actually doing a silent disco. So my name's Alex Housley. I'm founder and CEO at Seldon, and we are a machine learning deployment platform. So we focus on the later stages of your machine learning projects when you're moving out of R&D and into production. Machine learning is obviously revolutionizing every industry and changing our lives. Obviously, there's a lot of hype out there, and sometimes it can be quite hard to sort of find the signal in all the noise. But one thing's for sure, spending on AI has increased from $12 billion last year to $57 billion in 2021. Organizations are using it to create deeper and faster insights on their business, on their customers, to create smarter applications, to reduce costs, reduce risk, and automate internal processes. So over the next few years, what are the magic properties of machine learning is really that just a relatively small number of techniques can apply across industries and across use cases. So here's some analysis from McKinsey. The dark shaded squares here are use cases that apply to specific techniques. And over the next few years, and right now, the emerging technology that's really taking off is around deep learning. And what they classify here is focusing on AI. These deep learning techniques have an uplift of on average, about 62% above the analytics techniques that people have been using previously. So organizations will be, over the next few years, converting millions of handcrafted rules into machine learning models that are constantly learning and evolving. And this presents a huge challenge for organizations because these models need to be deployed. And deploying machine learning requires specialized skills and specialized infrastructure. So our purpose at Seldon is to help people predict and shape the future with machine learning. And we do that by helping data science teams to succeed in deploying machine learning models. So data science teams are not just data scientists. Data scientists are building models. Then they have to hand these models over to someone to actually put into production. So these broadly are DevOps people. And DevOps engineers are typically don't have as much of a background in machine learning. And then business people obviously are investing in and trying to solve real business problems. So it's important that they're not disenfranchised from the actual deployment process. There's a very short loop between the data science team and a measurement of impact on KPIs and ultimately the ROI that the projects bring. So to go into more detail, data scientists, there's a huge skills shortage. And much of their time gets spent on data wrangling and then increasingly so on deployment. So, if a quarter of your data science team's time is spent on packaging up models, creating containers, on quality of service and performance-related issues, that takes them away from actually building better models, doing the data science where they can add the most impact on your business. And there are some collaboration and compliance challenges. The DevOps engineers require a multidisciplinary skill set. And there are huge inefficiencies in building and maintaining machine learning infrastructure. And actually, one of the complexities within a DevOps team is that the processes for version controlling software have not been used so readily within this world. And this is very important for reproducibility of models and due to the complexity of the amount of experiments that's required to create an optimal machine learning application. And as I said, the business managers require a very close loop between the ROI and the performance of the machine learning models. And machine learning presents some new complex regulatory challenges. It's important that organizations are able to explain the impact of their machine learning models and why they made certain decisions, and to avoid things like bias in the models. Obviously, GDPR and privacy also require a much greater understanding of what data has impacted been used to build algorithms, and the lineage between the data and the model is a technical challenge in itself. So at Seldon, we've been using a technology called Kubernetes since 2016. Who here is aware of Kubernetes? Can I see a sort of, great, okay, awesome. So for anyone who's unaware, very briefly, Kubernetes is a technology that came out of Google. It's a large-scale compute platform that allows you to deploy full architectures of Docker containers. And that's a much more efficient way of packaging up software without having the overhead, the bloat of having to deploy the operating system within each and every container. So why is machine learning complex then? So most people think about machine learning as being building a model, creating an algorithm, and what actually is required to actually put a machine learning model into production is a full end-to-end pipeline that starts with data ingestion, data transformations, going through to training at scale. And once you've actually built a model, you then have to think about how you roll it out in production, how you create experiments. And where we're focused on at Seldon is on this late stage of the machine learning pipeline. And this is what our open source product, Seldon Core, solves on behalf of enterprises, makes it much, much easier to roll out your models. So Kubernetes, one of the great advantages of Kubernetes is that it abstracts away a lot of the complexities of the underlying infrastructure. So things like the auto-scaling and making the correct resources available for your machine learning projects can be dealt with much more efficiently through a Kubernetes interface. So it's now supported by all the major cloud platforms. It is compatible with on-prem installs. So it has much less, or no, doesn't have the same lock-in as kind of a machine learning as a service API. Also, it handles a lot of the kind of requirements that the businesses have across industries, things like role-based access controls, security, scaling, etc. So a lot of projects have been built on top of Kubernetes, and Seldon Core is one of them. So let's go deeper into machine learning deployment and the goals that we have when setting about creating Seldon Core. So first, within deployment, you've got to think about how you actually not just launch, not just get from 0 to 1, but how do you actually scale when you get increased demand. Also, one of the biggest risks within any machine learning project is when you roll out a new version of a model. So, you can either cross your fingers and just hope that it works well and, it doesn't cause any negative impact on your business, or you can take a strategic approach of doing a kind of canary test where you roll out the model to a small number of people, assess its performance, and then when you're ready, do a rolling update. So there are various different strategies which I'll go into in this talk. And then there's health checks and recovery. So, constant monitoring and being able to roll back. The infrastructure and the models themselves need to be optimized at runtime. So, for example, picking the model which is performing best at any one time and ensuring it's running on the correct infrastructure. Any machine learning model needs to connect within your business applications. And it is possible to export models and to plug them directly into your application code base. But this causes new overheads as the data science team end up getting fused onto the release cycle of your product team. So what we're seeing now is machine learning is more and more delivered via API interfaces. And what we provide out of the box with Seldon is a REST API, which is very common, and then a gRPC API, which is much more sort of lightweight, much more efficient. And not all machine learning models give an instant result or should give an instant result. In some cases, maybe you want to get make a decision on the fly or get a recommendation or a credit check immediately. But there are many use cases where you don't need an instant response, or you may have a lot of requests to deal with. So you could have an environment where you need to deliver a risk assessment on a new business account. The report needs to be handed in tomorrow, but not immediately. and it requires churning a huge amount of data, and those kind of asynchronous queues provide another technical challenge which we're solving. And then the ultimate model management. So model management includes the ability to audit every single decision that went into the process of releasing a new model. So this is effectively a way of putting a log over the workflow that the team have gone through to create a new model. And the approval of machine learning models also causes big bottlenecks within organizations, as you have to do a huge paper trail to understand exactly what changed and the impact on the business, and that often slows down the release to production. As I mentioned, data provenance, understanding which data informed which model, and constant monitoring, and then a technique which has really been taking off around kind of deploying applications at scale is around continuous integration and continuous deployment. So when people are releasing code, this triggers new processes which kick off a production process. And a technique that we use heavily at Seldon is around GitOps, which we're building around, which enables you to check new source code into Git, and that will fire off a process to release that code. And the reason we can do that is now that the actual infrastructure is also declared in a sort of declarative format, so you can see in a config file what has changed. We also have people using a variety of different frameworks. So there's, over the last 2 years, a number of great open source projects have emerged, like TensorFlow, but there are many more, like PyTorch. But there are other languages like R and Java with things like deep learning for J and Spark. And so it's important that your data science team has the agility to use the tools which are best for the job at any one time and not be forced to use any specific framework or ecosystem. And then what we've done at Seldon is enable you to create a dynamic, what we call like runtime inference graph, which which allows you to not just deploy one model, but to deploy multiple models, which are connected by components which allow you to create an experiment or an ensemble, or to append new data to the output. So you can, for example, append like an explanation score. So in brief, the process is to package a model, describe the deployment, and then deploy. Very easy to install through a thing called Helm, which is effectively like a package management system for Kubernetes. You then wrap up your models. So we have wrappers that work across libraries. And then you describe your runtime graph in YAML, which actually is deployable via the Kubernetes command line interface, which is called kubectl. So it's using the tools which people are already familiar with rather than introducing new techniques. Each company would have their own private container registry. So the data scientists, the workflow is to check their new models into those registries, and then they'll be deployed. So I won't go into all the detail on the architecture here, other than to say you have data science teams that are interfacing via the CI/CD and kubectl. But the business applications are interfacing via the REST APIs and gRPC. And so these are the four components I mentioned earlier. So the models themselves, obviously can be built using a variety of different tools. But the other components we use to create these inference graphs are routers to, for example, create an A/B test. But you could also create like a multi-arm bandit, which is like a more dynamic A/B test, which allows you to select the model that's performing best at any one time, to create ensembles on the fly, and to, in those transformers, you can also, as well as appending explanations, you can do concept drift alerts, which allows you to see if a model is going out of date and needs retraining, and outlier detection to see if it's delivering results which are outside of your expected range and could lead to some sort of issues. So here's an example of what this complex graph would look like. So rather than deploying a single model, you can deploy multiple models which are connected by an A/B test, or a multi-arm bandit in this case. Behind that, you can put a feature transformation, which the client can use to actually change their data as it's flowing through the system. Outlier detection is another module, and then an explainer at the top. So this full package, it can be defined in this YAML file. So this example here, you've got the graph definition here. I don't know if you can read this. Up here is the pod specification for Kubernetes, and then the list of predictors. So the great thing about this are things like the resources and the containers and everything which is necessary for that deployment is declared in this YAML file, which you can version control, and you can have reproducibility of the interface. So in the interest of time, I will just very briefly go through one of these examples of a canary test. So rather than having one model with 10 replicas running live and then immediately deploying a new model, you would create a model B and serve maybe 10% of the traffic to that model with a single replica. And when you're ready to do a rolling update, you can put model B into production. So you have similar things for blue and green deployment. So you can actually have 2 live deployments going at any one time, flip to the next one if one falls over. Shadow deployment example would be in a credit, in an FX market, you want to test a new strategy, do some trades without actually executing on them and see what would have happened, which is incredibly useful, and this is a shadow deployment. So I won't go into detail on how to package them. You can get the decks by taking a photo, and I'll tweet it out later. It's very easy to package up your model across a variety of different languages. And this is R, Java, Python. The API basically allows you to request predictions, also to create a feedback loop so that you can actually create a reward mechanism, which is used to feed into the model to create things like the multi-arm bandit. So I'm going to wrap up there. This is our roadmap, which you can read. And if you want to hear more about Seldon, you can come to the Meet the Speaker session, where we can go dive into more detail on this and our future plans. Final word is we run TensorFlow London. So if any of you want to sort of go deep on TensorFlow and learn from some of the best machine learning companies in the world, people like DeepMind, et cetera, we host monthly events. So search for it, TensorFlow London, it's Meetup, and we'd love to see some of you there. Thank you.